So last class we talked about law of sines, finding missing sides of triangles that don't have right angles. We ran into some issues on problems that look like this. So let's say I have angle A is 31 degrees, side A is 18 feet, and side B is 41 feet. Can we solve this triangle? Well, of course, our standard picture for triangles is going to look something like this. Label our angles A, B, and C. Once we've done that, we can label our sides by the opposite angles. So A, B, and C. Here we know that angle A is 31 degrees. Side A, 18 feet, and side B is 41 feet. Tell me what to do from here. So set up our proportions. So we've got 18 over the sine of 31 degrees equals 41 is our only other piece of information, and its opposite angle is B. So over the sine of B, we will cross multiply and divide. Sine of 31 times 41 divided by 18. So sine of 31, make sure we close the parentheses, times 41 divided by 18, and we get 1.173. Sine of B is 1.173. So we'd have to do the inverse sine to find B, correct? Say no. What's that? No. Hey, yes, a sine can never be larger than 1. If we try to inverse sine this, our calculator is going to give us an error. Remember what that is saying is this side here, the 18 feet, is not long enough to reach down to that. This does not make a triangle, is what that's telling us. So let's try another one. This time A is going to be 28 degrees. Side little a will be 21 feet. And side little b will be 38 feet. So I'm going to label my triangle. So I'm going to put in the information I know. A is 28 degrees, little a is 21 feet, and little b is 38 feet. So now what am I going to do? 21 over the sine of 28 degrees equals 38 over its opposite angle is b, so over the sine of b. Looks very similar to what we did last time, only this time when we cross multiply and divide, it works out. Sine of 28 times 38 divided by 21. So sine of 28, make sure we close that parentheses, times 38 divided by 21. We get 0.8495. So sine of b is 0.8495, and remember when we're looking for the angles, we have to do that extra step, which is the inverse sine. So on my calculator, I just do second sine, second answer, to get the angle. So 58.16 degrees. Is that my angle? Not necessarily. Remember, this triangle that I drew here was not given. I just drew it to fit the information in. You'll notice there's one piece of information I snuck in there on you. That right there, what's that telling us? That b is greater than 90. In other words, it is obtuse. So in other words, this triangle actually looks more like this. So here's angle B right here. This is side C, and this is angle B. That's an obtuse angle. How do we find what that actual angle is? Not 90. Good idea. It's 180 minus the 58.16 degrees, which is going to give us 121.84 degrees. And from there, then we can find this last angle over here, which is going to be 30.16 degrees. How do I get that? Well, it's 180 minus the 28 and the 121.84. And then, of course, we can find angle C using our law of sines. Okay, so enough of our review. The new stuff for today. What happens when we don't have a side and its opposite angle? What happens when we see something like this? Now I'm going to label this in a specific way because the way the law is, the formula is written, it's easier if we have it labeled where C is the angle that's in between our two sides. Here we have two sides and one angle, but the angle is not opposite either of the sides. The angle is between the two sides. It's sometimes called two sides in the included angle. So we cannot do law of sines here in any form because we don't have a side and its opposite angle. So yes, here we are going to do the law of cosines. The law of cosines actually is going to look very familiar with a simpler rule that we've used quite a bit, and that is the Pythagorean theorem. For example, we might have, well, because I set it up this way with C over here, C squared is equal to A squared plus B squared. That should look pretty familiar, right? The law of cosines is sometimes called the generalized Pythagorean theorem, because that is just the Pythagorean theorem there, but now there's an adjustment factor because angle C is not 90 degrees. So it's minus 2 times A times B times the cosine of angle C. So how does that work? Well, C squared. I'm actually going to adjust this. I'm going to take the square root of this. So it's going to be written as C equals the square root of A squared plus B squared minus 2AB cosine C. So for this particular problem, C equals the square root of 39 squared plus 42 squared minus 2 times 39 times 42 times the cosine of 39 degrees. So let's punch this in and see what comes out. Square root of 39 squared plus 42 squared minus 2 times 39 times 42 times the cosine 39 degrees. Now on my calculator, I just have to close the parentheses once to end the cosine. On your calculator, you'll probably have to close the parentheses twice. You have to close it once to end the cosine, and you have to close it a second time to end the square root. My calculator puts the square root symbol over it, so I don't have to do the second ending parentheses. Andrew, on yours, of course, since you have a graphing calculator, you probably don't have to use the second one either. So I'm going to hit equals, and I get 27.19 feet. So C equals 27.19 feet. Okay, so now I have a side, the 27.19, and its opposite angle, 39 degrees. I can go back to law of sines. So I can find the other two angles with just using the law of sines. Now here's a little hint to keep you from making a mistake. Always, obviously I'm going to use the 27.19 over 39 degrees. So over the sine of 39 degrees. Because that's the only corresponding side and angle that I have. When I go to find the next angle, I could use either the 39 feet or the 42 feet. Always use the smaller of the sides. There's a good reason for that. Remember up here where that one angle was obtuse? Well, down here, we don't know for sure whether... all we know that B is the largest angle because it's opposite the largest side. We don't know whether it's obtuse or acute. We do know that there never is more than one obtuse angle. So we know that this angle has to be acute. Make sense? So if we just find this angle first, we can subtract from 180 to get this one. Rather than finding that angle and deciding, do we have to adjust it for being obtuse or not? It saves us some mistakes. So always use the smaller of the two sides to find the smaller of the remaining angles first. You don't have to worry about it. So that's going to be 39 feet over the sine of A. So we shall cross, multiply and divide again. Sine of 39 degrees times 39 feet divided by 27.19 feet. So cosine of 39, close my parentheses, times 39 divided by 27.19 equals 0.9027. And we do our inverse sine to get that A equals, so second sine, second answer, 64.51 degrees. Questions? Okay, so this is 64.51. And then this angle here is going to be found by subtracting from 180. So we've got, what, 103.51 from 180 is going to leave us with 76.49 degrees there. What do y'all think? Can you handle it? The law of cosines allows us to do another small variation, which looks like this. A triangle where I have all three sides. Now remember, I told you guys a week or so ago, triangle has 6 parts, 3 angles, 3 sides. And if we have any 3 of those parts, as long as it's not all 3 angles, as long as it's at least one side, we can find all of the missing pieces. So if we had all 3 angles, of course, it could be any size, so that didn't work. That was the only combination that didn't work. And we have not looked at one yet, until just now, that has all 3 sides. We can find the angles. So I'm going to label this A, B, and C. So this is side little a, little b, little c. The angles. Remember, c squared equals a squared plus b squared minus 2ab cosine c. There is an angle in this formula, and only one angle in this formula, c. So if I were to solve this for the cosine of c, I could use it to find an angle. Solving that for the cosine of c, I'm going to subtract a squared, and I'm going to subtract b squared from both sides. So now over here I have c squared minus a squared minus b squared equals a negative 2ab cosine c. I'm going to divide by negative 2ab. So what I have here, now that I've solved this, is the cosine of angle C is equal to c squared minus a squared minus b squared over a negative 2 times a times b. Now if I'm going to use this in the calculator, there's going to be some parentheses that are going to have to go in. Here and here. So I'll do second. I'm putting my parentheses, or sorry, no second, sorry, clear this out. Parentheses. C, I'll put in some numbers here. Those are 32, 46, and 48 are my sides. So for this triangle, it's going to be 32 squared minus 46 squared minus 48 squared, close my parentheses, divided by, and I have to open my parentheses again, now for the negative, make sure you don't use the subtraction, use the negative down here. Negative 2 times a is 46 times b is 48. Close my parentheses again, and I hit equals. 0.7690. That is the cosine of c. So I do inverse cosine. So second cosine, second answer. 39.73 degrees. And of course, once I have that angle, now I have an angle on its opposite side. I am back to using the law of sines. Which of these two angles would I want to find first, A or B? 39.73. There is a definite which one I'd want to find first, A or B. A, why? It's smaller. It's opposite the smaller side. Always find the smaller angle first if you can. What do y'all think? Good stuff? Go down.
When's this drill going?
Next 5 or 10 minutes. Yep. Yep. Right there. Yep, I got the 0.7690. That was the cosine of C. And if you wanted to, you could do it all in one big step where you could say C equals the inverse cosine of, C squared minus A squared minus B squared. But then you have to have a second set parentheses there. Divided by -2 times A times B close and close. Like that. That would work. Making sure you put 39.73 was my angle. Then it's law of sines. It's just 32 over sine of 39.73 equals 46 over sine of A. Remember, always use the smaller of the remaining sides first. On page 787 of your book, doing an exercise 36-11. Page 792, you're looking at exercise 36-13. Give those a shot.